Good evening, everyone. Welcome to this tech workshop on developing web applications with routing services available with ArcGIS Online. Thank you for attending the very last, oops, please see. Okay, I'll not touch that cable anymore. Thank you for attending the very last tech workshop. We have the Esri party starting right after this workshop. So hopefully you'll hang on for 1 hour. You'll not even realize 1 hour is gone and we can all go to the party. So I am Deelesh Mandloi and helping me is my colleague Dmitry.
Good evening, everyone.
Both of us work with the routing services. I speak Python, Dmitry speaks JavaScript. So there we go. So before we start, the slides as well as all the code that we will show in this workshop are all available at that URL. So if you want to note down something or take a picture of this slide so that everything that we talk and show, you can always get back to it once you go back. I'll stop for a few seconds before all of you can get it. Also, I'd like to mention if you want to know one URL where you can find all the information and the documentation and getting started and everything, the landing page that you want, that would be that page on developers.arcgis.com, features, directions. There it will cover all what we are talking about with additional links to detailed API reference and code samples and everything. And if you are going through that page and learning about the services, a recommendation is first read the REST API doc so you understand what the services are doing, and then read the SDK in which you are building your apps. Okay, so what we will be covering in this is what routing services are available with ArcGIS Online, what you can do with these services, how you can access the services, and we'll see two patterns there, how you access these services using the REST API so that you know the overall concepts, and as a programming language we will see how you can access these services in ArcGIS API for JavaScript. Now this doesn't mean you cannot access these services in all of the other supported SDKs with ArcGIS platform. You can access them in all, but for this workshop we'll focus on REST API and JavaScript. Then we will look at how much would these services cost to you. For developing, it's free, and there's a fine print to it that you cannot use it for free with production. So we'll look at it, how much it costs, what you can do with it. And then finally, I'll leave it to Dmitry and he'll show you how to use all these services and build an app using the web app builder. So directions and routing services are a collection of these 7 services. So these services help you to solve transportation problems on street networks. Not your utility networks or things like that, it's just strictly street network that Esri provides for you. So there are services that help you to do point-to-point routing, finding closest facilities, finding areas of reach from your facilities, visualizing live traffic speeds along with traffic incidents, solving fleet optimization problems, solving facility location problems, or generating travel time or travel distance matrices. So we'll look at all these 7 services in a bit more detail in the subsequent slides. Now, before we get there, some things that are common to all of these services, which is these work globally. So depending on your area of interest, you can make sure these services are working. Now they use high quality street data that is sourced from various different data vendors. They support predictive and real-time traffic wherever that kind of data is available. They support advanced logistics attributes like the weight and the height restrictions for the vehicles and other things. They also support additional attributes like streets that should be preferred when finding truck routes or routes that should avoid toll roads and so on. And they also support travel modes. So Esri provides you up to 8 predefined travel modes to do analysis using driving, walking, or trucking as your modes. And you can also define your own travel modes and then use with these services. So your own travel mode example would be you take the Esri's trucking travel mode, add some customizations to it. Maybe you're routing a vehicle which is of certain height, so you can apply that height restriction and that becomes your own travel mode, and then you can use with these services. Here I've provided a link for a coverage map that shows what kind of coverage is available for these services, and where you have the data quality. Like in some countries, the data quality would be best. Some countries, there would be some features missing, so this coverage map will give you that. Also common to these services are execution modes. Now, each of the service supports up to 2 execution modes. So they support either they support synchronous and asynchronous. Some services might be just synchronous, some services might be asynchronous, some services might be both. So what's the difference? Now, you use synchronous modes for requests that execute very, very quickly. You use asynchronous mode for long-running requests. So essentially with the synchronous mode, you submit a request, you get back a response. And that period should not be, say, more than 30 seconds, or at least not more than 60 seconds. With asynchronous execution mode, you submit a request, you get a job ID back, then you poll for that job status. You say, oh, given this job ID, is this job done? You poll for it until that job is done. Once the job is done, or it succeeded or either failed, you get back the results or the messages. So it's just an implementation pattern that any of your APIs and SDKs need to follow. Is if it's synchronous, it's like you make a call, you wait for the app for that call to complete, and you get back the results. For asynchronous, you submit the job, you poll for the job to complete. Meanwhile, your app can be responsive and doing other things. When you get back the results, you just draw them in your app or do something with it in their app. Also common to all services that create routes is the ability to save those results as route layers. Now, this is something new that has been added in the last 6 to 8 months. So you can run an analysis that, say, generate 5 routes, save each of the routes as a route layer. A route layer is an item in the portal, so you can work with it like any other item, like a web map or a feature layer that you would have worked in past. So once you have a route layer item, you can either edit it back using the directions widget in JavaScript API or in map viewer. You can share that item with anyone in your organization so they can have access to a route. Or in future releases, other Esri apps like Navigator for ArcGIS would be able to consume that route layer item, and then they would be able to use that route layer item. So in a future release of Navigator, you would be able to, say, plan your routes using the routing services, share the results as route layers, and then your drivers who are running Navigator device in the field can get your routes and they can execute the workflow in the field. So look for that in the future releases of Navigator for ArcGIS. So before looking at all of these services and the details, I would switch over to Dmitry, and he has a problem that he will describe.
Thank you, Deelesh. Yes, we just about like 5 minutes before the session, we decided to restructure our flow a little bit to keep you entertained and minds busy. So we are going to tell you about this problem here we are looking at right now, and ask you if you are not tired too much by this moment. Just as Deelesh will keep talking about different services and tools and widgets, to think how would you solve this problem. So this is a very simple story about a little pizza shop in San Francisco called San Francisco Pizza Load Balancer, which is growing fairly fast. Their pizza is popular, and they get about like 60-70 pizza delivery requests per hour. 3, 4, 5 vehicles to deliver these pizzas across the town in Oakland, a little bit to the north as well. Sometimes, depending on the day on time of the day and day of the week. But they also kind of running late often, and they need to figure out how to quickly build routes, optimal routes, and balance the load across the different vehicles. This is what the developer of that little company came to. Essentially, he or she heard about this cool place called ArcGIS.com and network services, and he just decided to try it out and see what happens. So he just pulled a CSV file from the call center with the recent 37, in this particular case, pizza requests, and dropped that CSV file on the map, and it got placed with this in form of these little pink dots over there. He also digitized this little star location. This is where the business operates from when the vehicles are departing, loaded with pizza. And what to do next. And I guess this is what we will show you a little bit later. Get back to English.
So hopefully with the knowledge that we'll have, we will be able to solve this problem. That's what we'll see by the end of how and we are solving that. So looking at the different services, we first start with the direction service or the routing service. This service allows you to do your point-to-point routing between one or more stops, which is what we call as simple routes. It also supports the ability to optimize the sequence in which you visit the stops such that it minimizes the overall travel time and travel distance. These are called as optimized routes. Now, along with optimizing the sequence, with either mode, simple route or optimized route, you can use live traffic conditions. So you can say, find me route that honors the current live traffic conditions, or it's based on predictive traffic, or it's based on traffic as observed on a typical Monday at 8 a.m. So all those capabilities are available. It supports travel directions in many languages. I think up to 21 languages are supported, so you can generate directions in Spanish and all the languages supported. And it supports both synchronous as well as asynchronous mode. So if you are doing a few quick routes, you would want to do synchronous. If you are doing batch processing of a lot of routes, you might want to do the asynchronous execution mode. So an example endpoint and how you would make a request if you're using the REST endpoint. So this is for synchronous execution. The service is available on route.arcgis.com, and at minimum it just requires stops, and you can specify stops as lat-long pairs. So in the example request below, I'm just specifying two stops, start stop and end stop, using their lat-long values, and I put in my token and I can get back a response which will include the routes as well as driving directions between those 2 points. Very easy and simple to use in the basic mode, but as you keep on adding parameters to that REST endpoint, you can exercise all the different functionality available with the service. That was REST, but say if you are writing a web app in JavaScript, how would you access this service? You can of course make the REST request from JavaScript, but that won't be that much of fun. So JavaScript provides you very easy ways to execute this service. The easiest by far is using the directions widget. So you initialize the directions widget and it shows up in the map container, and it has a predefined user interface that allows you to exercise a lot of functionality. So if you just need to enable the routing capability in your web map, just go initialize the directions widget in your web app container, and there you go. You have just enabled routing for your app. Along with that, if you say really want to get into the details of things, build your own UI and maybe exercise other functionality, you can always use the route task class in the JavaScript API, which gives you access to all the different functionality available with the service. If you want to do the asynchronous execution mode, say you have a spreadsheet of start location and end locations, you want to find travel distances and travel times between all of those start and end pairs, you may end up using this connect origins to destinations analysis widget in your app. Or if you want to really exercise the asynchronous execution pattern through JavaScript code, you can use the geoprocessor class. Now, this pattern I will show for all the different services. How you execute it from REST, how do you execute the synchronous execution from JavaScript using widgets or using the API class, and same thing for the asynchronous execution mode using a widget or using the API itself. The second service is the closest facility service. It allows you to find one or more locations that are closer or closest to the location of your interest. So say for example, there's a crime incident and you want to dispatch 3 closest police cars to that crime incident, this service can help you do that. So along with finding the closest facilities, which would be police cars, from each incident, in which case this would be crime incident, it can generate routes as well as driving directions. So you can see this does the functionality of the routing service along with finding the proximity. You might have seen near me or nearby in many of the apps, which are mostly using Euclidean distance, but this service is actually using travel time or travel distance to find things nearest to you and can also route to that. So it uses traffic conditions like the route service. You can limit the search distance. You can say, oh no, find me only things that are within 5 minutes or within 5 miles. You can limit the number of facilities to find. So instead of dispatching 3 closest police cars, you can say only dispatch me 2 closest. You can also specify the direction of travel. So in this case, the direction of travel is from facility to incident. But say if you are routing an ambulance from a traffic incident to the hospital, then the direction would be from incident to facility. So you can specify the direction in which you are traveling, and this service also supports synchronous and asynchronous execution mode. So again, for synchronous execution, the URL is simple. You call the solve closest facility operation, and you pass XYs for incident and facilities, along with other parameters which would be optional. In JavaScript API, there is no directions widget kind of functionality. You have to build your own if you want to quickly expose the synchronous endpoint. If you want to build a UI for an asynchronous execution, you can use the find nearest analysis widget, or if you want to use the class, geoprocessor class, you can use that. If you are doing synchronous execution, you can use the closest facility task in the JavaScript API. Again, these URLs are hyperlinked to actual API reference, so you can see with detailed examples how to get familiar using the class or the widget. That's why the slides when you get back would be useful. The third service that we have is a service area service. This service allows you to generate pretty looking polygons. Well, polygons are good, everyone in GIS understands them, but these polygons have meanings. These polygons are areas that you can reach if you start traveling away from your location or traveling towards your location. So they kind of define the travel areas or trade areas around your points of interest. Now, you can solve for one or more locations around which you're generating your travel areas. You can use multiple drive time or travel time values. So you can say, give me 5, 10, and 15-minute walk time areas around my store locations. So then once you have those polygons, you can figure out maybe how many customers are within, potential customers are within those walk time areas that you have just calculated. You can analyze for different times of the day. So say if you're using the driving mode, you can see how the areas shrink and grow based on the traffic conditions. So during rush hour traffic, the area of reach would be quite small. During free flow traffic, the area of reach would be a lot bigger. And they support synchronous as well as asynchronous execution. So for synchronous execution, it's on the solve service area endpoint, and you need to specify the XY coordinates of the facilities at minimum. By default, it will give you 5, 10, and 15-minute driving time, but as you change the parameters, you can exercise all the different options. If you want to put this service in your app, for synchronous execution, you have to build your own UI and use the service area task. For asynchronous execution, there's create drive time areas analysis widget or the geoprocessor class to get to the service in your code. The next service is the vehicle routing problem service. This service allows you to optimize a fleet of vehicles, or if you have more than one drivers servicing a set of orders. It's a slight hint. We were talking about this in the scenario, right? We'll see later. So along with optimizing your fleet, this service allows you to specify a lot of logistical constraints. Your vehicles can have capacities. The orders that you service might need certain specialities, like if you are furniture delivery, you can service a particular delivery only with a certain type of vehicle. Your organization may have constraints saying each driver needs at least 2 breaks. So you can specify my driver can work only 8 hours and he or she needs to have 2 30-minute breaks during their workday. You can have time windows on your order. So you can say, oh, the first preferred time window on this order is from 9 a.m. to 10 a.m. Or if you cannot make delivery during that time, try delivering this order between 3 p.m. and 4 p.m. So you can specify all those constraints, and given a set of orders and a set of vehicles that you can service those orders, this service will find out which orders should go on which routes and then figure out the optimal sequence in which to visit those orders. So it's solving a lot of challenging logistical problems. Now this service, I'm here showing you an example of asynchronous execution. It needs to follow that pattern. You first submit a job, giving all the parameters. You get the job status. Once you submit the job, you get back a job ID in the response. Given that job ID, you poll for the job status, saying is the job executing, or is it failed, or is it succeeded, or succeeded with warnings, and so on. And once you know the job either failed or succeeded, you can start either retrieving the messages in case it failed to figure out why it failed, or you can get the outputs. If the job succeeded, you can get the outputs and then start working with the outputs. So any asynchronous execution, you're always following this pattern: submit job, get job status, get outputs. Now, if you're using the asynchronous execution mode in some API, like the geoprocessor class in the JavaScript API, the API might wrap these things behind the scenes, so you may never have to do this polling and all. The API might make it really simple, saying, give me all the parameters, I will wait for the execution of the job, and then I'll give you back all the results. But you should understand that this is what is going to happen behind the scenes, because that's what the REST endpoint really supports. If you want to use this service in a JavaScript app, the asynchronous execution mode, you have the plan routes analysis widget, and you can use the geoprocessor class if you are using it in code. The next service is location allocation, and this allows you to solve facility location problem. What do I mean by that? Let me give you an example. Say you are in a fire department and you want to plan a location, or you want to cite a location for a new fire station such that the overall coverage of the neighborhood is improved. So you figured out by running some analysis, probably service area analysis, you took your existing fire stations, drew 1, 2, and 3 minute travel times along the fire stations, and then figure out, oh, there are holes in my community. I need to probably come up with a new location for a fire station. It could be a new location for a store, for that matter. So using this service, you can figure out from the 10 or 15 candidate locations that I may have selected based on many different criterias, like they have the right zoning and the right price and so on. You can give it to this service saying, these are all my demands. My demands could be census block groups, or it could be just the centroids of each of the street in my neighborhood. These are all my candidate locations. Maybe you have existing facilities, so these are all my existing facilities. Find me 2 best facilities that will minimize some kind of criteria. Either you want to minimize travel, or you want to maximize coverage, or your facilities would have capacity, so you want to maximize coverage, including the capacity constraints. So all these different kinds of facility location problems are supported by this service. Now it supports only asynchronous execution mode, and because these types of problems usually take a lot longer than 60 seconds to solve, so there is no point in supporting a synchronous execution mode, and you need to follow the asynchronous execution pattern. Now, if you're building a UI around this, the JavaScript API comes up with a very good widget called Choose Best Facilities. That is really a wizard-driven widget where you first select the problem type. There are 5 different problem types that are supported, and based on the problem type, you would see the parameters that are applicable to that problem type, and then you can pass in those parameter values and solve a particular facility location problem. So I would say if you are interested in this service, definitely give a try to this widget, because building a user interface around this service can be quite complex. The next service is Origin Destination Cost Matrix. This service is in beta, which means essentially the API is fixed, but it's free to use, will not charge credits while it is in beta. Once it moves out of beta, we'll put a business model around it, and then you will need to know how much credits it will cost to use this service. What does this do? This service allows you to measure travel time and travel distance between all of your origins and all of your destinations. So it doesn't return the route shapes. It will just give you the travel time and travel distance values that you can then use for some other purpose. And again, it is between all origins and all destinations. Oftentimes we get people who have origin destination pair. So an origin connects to only one destination, and because of the name of this service, they end up using this. This is not the service to use if you have predefined origin destination pairs. This is the service to use if you want to find travel time and travel distance between from all of your origins to all of your destinations, or all of your origins to first n of your destination. So it's kind of a matrix that you're trying to calculate. Use this. If you just have predefined pairs, use the route service. Again, this also only supports asynchronous execution, because usually the execution time is greater than 60 seconds and follows the same execution pattern. Now, there is no widget to access this service, because most of the time it's used as a step to execute something else or run something else. So you go ahead and use the geoprocessor class in the JavaScript API to access this. Now, there is a little helper service called utilities that provides you auxiliary information for working with all the routing services that we talked about. So I mentioned all the services support travel modes. You as a developer, how would you know the list of travel modes that are supported by all of these services? Like I told you, by default, services support these 8 travel modes. You can define your own. As an app developer, how would you know all the travel modes that are supported? So you use this utility service. There is a tool called get travel modes, which can give you a list of all the supported travel modes that you may want to populate in a user interface like this, and then based on the travel mode that the user selected, go ahead and execute the service. The services also support limits. Like you cannot solve a 10,000 by 10,000 OD matrix problem with the service. That will just take too long to execute. So each service poses a limit on the number of facilities that you can solve, or the maximum number of stops that you can put on a route. How do you discover those limits? Of course, you can read the documentation and figure out, but if you want to programmatically discover those limits, you can call getToolInfo service within the utility service, and that will tell you based on the service name the limits implemented on that service. Now this is a synchronous service, so it's meant to return really quickly. So say this is a request that you would do to get all the travel modes supported in your ArcGIS Online organization. And if you are in the JavaScript API, you would use the geoprocessor class. The last service is the traffic service. Now this is not really an analysis service, it's a visualization service that allows you to visualize traffic speeds. So if you want to show a layer in your map which shows what the current traffic looks like, this is the service to use. Along with showing the traffic speeds, you can also show traffic incidents, and these traffic incidents actually have JSON data. Data including when was that incident started, when it is supposed to end, and when was it last updated, and so on. So you can use this as a very good operational layer if you are doing a routing app. The same traffic data is used in the analysis. So say if you are doing a routing app, you may want to draw this as a visualization layer, so you would know when you say route me using current traffic, why a route is going certain way, because maybe there is traffic in the expected way that you would take if there was no traffic. The data for this is live, it's updated every 5 minutes, and if you're using this service in your app, it only supports synchronous mode. So this is the REST endpoint, and usually you pass a bounding box. This is the extent for which you want that image, which will show you the traffic and the incidents, along with a time extent. So you would say if you don't pass a time extent, the time extent is now, so it will always give you a traffic for now, or you can pass in a time extent and get traffic at a certain time of day. How do you use this? You can use the traffic web map and draw that web map, or you can use the ArcGIS dynamic map service layer and pass in the layer ID for this traffic map service and draw it in your app. So those were all the services. Now how do you access these services? So all these services are secured and they require an ArcGIS Online subscription along with service credits to access them. Now we'll break this statement down so you understand how this is. This part is important because you know you like the functionality and all those, but if you cannot unlock the key, then you cannot access them, right? So essentially what it means is when you're making a request, you need to pass a token that would authenticate you, saying you are a valid user and you have enough credits to execute a service. So the aim of all this talk is how to get a token that you can use to execute the service. So if I go back a slide, you see in all my REST examples, I had token equal to your token. So essentially that your token, we will see how you can get that token so you can make the request. Okay, so first thing is you need an ArcGIS online subscription. If you're new to this, you can always get a free trial, which will give you 200 service credits, so you can try out all the services out without requiring anything. Or if you want to sign up for ArcGIS developer program, there is an essential plan which gives you 50 credits every month that you can use to develop against these services. You cannot deploy in production, but as you're building your app, you can always get 50 credits every month. If you run out of credits before the end of the month comes, then you have to wait till end of the month, but every month you get 50 credits that you can use to work with these services. Of course, there are paid plans which gives you more credits as you go on. So that's about the subscription. Now, how do you get that token? So there are actually two flows in which you can get the token. The first is all these flows are done through OAuth, and I have provided the documentation which has great details on how you can do this. But the one pattern is a user login pattern. What this pattern is, essentially your app asks the app user to provide their credentials. Then your app takes those credentials from the end user's username and password and exchanges that for a token, and then goes ahead and call the service. So that's the user login pattern. That's a valid pattern. I would say all of the SDKs provide an identity manager of some kind which you can use to follow this pattern. The next pattern is an app login pattern. So here your app logs in behind the scenes. So your end users are never challenged for any credentials. Your app knows how to work with the token behind the scenes. So the way you do it is you go to arcgis.com or developers.arcgis.com, register an app, and when you do the register an app, you get a client ID and client secret. And now based on this client ID and client secret, you can make a REST call that would give you the token, and then you use that token in your service. Now, you don't want to really embed that client ID and client secret in your, say, JavaScript code. So what's the common pattern here is to use a service proxy, which essentially stores these credentials secretly for you, and then you just get that proxy URL and use that proxy URL in your apps. You can always prevent abuse of that proxy URL by setting a rate limiting or referrer checks or things like that. Now, there are two ways of service proxies. You can use an ArcGIS online hosted proxy. That way you don't have to deal with any web servers or hosting those proxies on your own. Or you can self-host your proxy on a web server of your own, and then you can put your client ID and client secret in that self-hosted proxy. Now, the link here provides samples on GitHub for the self-hosted proxy. There are samples in PHP, .NET, and Java. So depending on the web server that you're using, you can actually host this proxy on your own. So that's how you get the token. Now what happens is every time you execute any of the services, you have to pay a certain number of service credits. That's the currency of ArcGIS Online. Each service for its successful execution will deduct different number of credits. How would you know which service deducts how many credits? I have provided a link there, but always keep in mind only successful execution will deduct credits, and you should have enough credits to run your services. Now, there are some exceptions. The traffic and the utility service, they don't deduct any credits. As long as you have a subscription, it's fine. And the origin destination cost matrix, as I said, it's in beta right now, so it will not deduct any credits, but everything else deducts credits based on the capabilities supported by a given service.
Plus waypoint manipulations as well.
Yes, Dmitry brings a good point. When you edit a route by adding waypoints, that also doesn't deduct credits. And there are different nuances on what deducts credits, how many credits are deducted, what does not deduct credit, and that link that I've provided explains all of those in detail. So now I'm going to switch it over to Dmitry, who is going to show how he solved the pizza load balancer problem using the set of services that we had seen.
All right, thank you, Deelesh. So I'm back to this application, the viewer application of arcgis.com. Well, after reading a little bit of a doc and playing with the UI, I figured quickly out that actually there is the analysis capability here associated with any feature collection or feature service added to the TOC layer. And just clicking through the things and options, looking at the different options, I quickly came across these plan routes tool which Deelesh was talking about. And this looks like this is what is going. This is very close to what I really need to do here. It takes my stops to visit, which is my customers layer. I can specify a travel mode here for the analysis. I can also specify depot where my routes are going to start from. It takes time as an input, which is good because really it means it will take into account historical and live traffic when my routes are being calculated. Usually my tracks take 15 to 30 minutes of time to load before departure, so I'm going to say that this is going to be, let's say, 6:30 p.m. They will return to the depot. Right now, at this point of time, I have 3 vehicles, for example, available in the depot. Usually we don't take more than 15 orders per vehicle. On average, it's about like 3 minutes per every stop to deliver the pizza to the door. And I don't want to overwork my drivers, so they will be limited by 8 hours drive time overall. I also need to specify the route layer name. This is important because this is how and under which name these results will be stored in my content in ArcGIS.com. So using my business rules, this is usually like May 9th and let's say 6:05 p.m. something like that. I also need to include route layers. Route layers, I will tell you in a second what this thing is about. Uncheck the use current map extent and click run analysis. It usually takes about like a minute and a half, maybe 2 minutes maximum to solve this kind of problems. This will produce, actually, this will take all the inputs, all the stops, and this particular depot, all the settings for the vehicles, and the service times for the stops, and solve it on the server side using live and historical traffic as a single mathematical optimization problem. Finding the best way to assign the stops to my 3 vehicles specified according to the special location of the stops, and evenly balancing the work time for my drivers. While working on this problem actually and fiddling around with different options, I figured out that, me as that pizza load balancer developer, I figured out quickly that there's a difference between the way how I'm adding the stops to this web map. My initial attempt was just to drop a CSV file on that web map. That produced a feature collection, which I could perfectly do my analysis on as well during my tests. But later down the road, I figured out that actually it's better to convert this feature collection into feature service, and then just populate that feature service once, for example, every half an hour, as soon as my call center collected enough requests for me to process as a route planner. Do you know what's the difference between feature collections and feature services? Okay, so feature collection is a JSON object which is stored inside my content. Feature service is actually a full-blown ArcGIS server service running in the cloud, which stores features with all the attributes and supports editing operations like update, add, remove features, supports also editor tracking, and so on and so forth. The reason why I switched from feature collection to feature service is because feature service comes with predefined schema and also with its own REST API for updates. So me as a fairly experienced developer in this field, in about like 15 minutes just wrote a simple Python script which takes now every half an hour the requests from my CRM system and pushes them through the REST API into that feature service, automatically bringing this ready to process requests into this web map. So I don't have to deal with CSV files anymore. So it already automated kind of a fairly good portion of the work which I have to do. But still, as you could see, I did a lot of interaction with this widget. I specified number of vehicles, start time, route layer name, service times per stops. I specified depot, a lot of checkboxes, itsy bitsy work, really busy work, which is also error prone and might cost me time, especially since I have to do it on and on again like 20 times a day. Every time there's enough orders for me to process to build the routes. Oh, sorry. Nevertheless, we got the routes built here. So let's see what we got here. We got 3 nice routes, blue, pink, and green. They are very well distributed. We got a fair distribution of load per vehicle. But the important thing is that I also checked that create route layers checkbox in the widget, which created along with the feature service right now, which stores these results, these routes. Also separate feature collections inside my content, which I can go to. And these are actually individual routes, which I can operate with any other item in my content. So I can share them, I can specify what users have access to them, and I can also further down the road will be able to load this route layer item inside Navigator for my drivers actually to navigate along. But if you take a look again at these routes here, me as a developer, as a dispatcher really, having some local knowledge and some business rules, I might want actually to do a fine-tuning of these routes before pushing them to Navigator, to drivers actually. To do that, I can actually use these route layers and individually opening them up inside the viewer again for fine-tuning using directions widget. So this is one of these routes which I'm bringing here in, and it got loaded. And for example, I don't want to this route to take, for example, this Treasure Island bridge, which will make it go all across the bay using a different bridge. And other manipulations like that, like for example, waypoint manipulations, so on and so forth. Then I can actually save this route again, and after that, push it to the Navigator. Right? Makes sense, and I think it's very powerful. No single line of code written. Workflow implemented right here. It can scale up to thousands of stops, hundreds of vehicles, right here. The problem though is that a lot of busy work which I have to do many times a day, error prone and expensive because I have to pay 1 credit per route. Every time I click solve or run analysis button, it takes credits. So what can I do? As a developer, after running this kind of workflow for about a week, I figured out that there's a lot of things which can be automated and should be automated. So I started reading more about it here and there, and I figured out that there's this thing called Web App Builder. How many of you know what this thing is about? Very good, very good. So Web App Builder, developer edition, very easy to get and to download. Where is it? Where is it? Where is it? Where is it? Sorry. Okay, here we go. So just downloaded the developer edition, put it on my machine. It comes with Node.js pre-configured. Very easy to start, very easy to develop for. A lot of nice documentation. Me personally, sorry, not as a pizza developer, but as a Esri JavaScript developer, I never worked with Web App Builder before. It just took me about 6 hours on Monday to come up with this widget, which I'm going to show you right now. Very easy, very straightforward. There is already like a demo widget for Web App Builder, which you can just take as a skeleton and just start pouring in the business logic into. And this is what I'm going to show you right now, what I got after about 6 man-hours probably of work. So this is a Web App Builder application, which has my custom widget put into. This is exactly the same web map which we just were looking at. That web map with 2 feature services was saved in my content, and when I configured my web app builder application, I just said that this is the web map which I'm going to work with. I also dropped the editor widget here. The search widget comes there as a standard thing. I didn't even have to do any configuration for this. And I also configured, put into essentially deployment folder my custom widget called Pizza Load Balancer. Cool. So let me show you what it lets me doing here. I'll collapse it for now. First of all, I see the same inputs here, which, as I mentioned before, backed up by feature service. So the content is dynamically updated every time, for example, the next round of route planning comes in. Also, I can now, using the editor widget, which is also part of the standard slew of web app builder widgets, I can easily add customers on the fly. Let's say that I got a last-minute call from a customer saying that he or she needs a pizza, for example, at 310 Market Street. Easy. Add a new customer. Here we go. We got a new customer here. This feature was just created in single click and pushed into the feature service ready for the analysis. But now, let's say, really, I didn't hear you well, and it was not 310, but 110. I just delete this feature, say 110, boom, I have another customer for me to work with. Very good. So let's open the widget now, the plan routes widget. This is a very similar UI to what you just have seen inside the viewer, because this is actually the plan routes widget, which I'm encompassing here inside my load balancer widget, gluing together it with directions widget together in a single wrapper. So here I also pre-populating all the inputs, which usually I had to place in manually. So I don't have to do any manual work right now, just click run analysis, and it will launch the same analysis on my inputs. Let me show you the code a little bit here. So this is just about slightly under 200 lines of code. And this thing instantiates 2 widgets inside. One is a plan routes widget, standard part of JavaScript SDK, and another one is directions widget, also part of JavaScript SDK. In order to minimize number of manual operations, I'm just specifying the default values here. So I'm specifying the portal standard things, my stops layer, start layer, also things to choose from. Then I also pre-populate the route start time, taking the current instantiation time, which is essentially the next 15 minutes interval here. I automatically generate output layer name. So it
just make your code screen white.
Oh, okay. Thank you. Also pre-populate route layer name, so I don't have to enter it manually according to the business standards here. Say route count, stops per route, and service time, and so on and so forth. Also, I'll automatically check this include route layers checkbox. And that's pretty much it. We just got the solution back, and let me show you what this widget also allows you to do. So earlier, I had to go into separate tab for the route layer to inspect and to open in another map and edit it there. Now, with this widget, actually, I can just click on the map, and it will actually bring the directions widget instance with this route populated. So I can start editing right here. Again, putting, for example, a barrier here for this one. Saving it. Then I will switch to editing another route. Okay, here, for example, add a waypoint. Oh, sorry, too fast. All right, again saving it. So essentially, I minimized the amount of manual operations here a lot. And the reason, or actually the way how I did it with directions widget is very straightforward. Once my result from plan routes widget comes back, I just add it as a separate feature layer here. And then upon a click on any of these routes, I initialize directions widget with its corresponding route layer item from portal, which actually initializes directions widget with all the predefined stubs and directions right away. All right, that's pretty much it for the demo. So thank you, and back to you, Deelesh.
So in closing, so fill out the surveys, and now we'll take up questions. Again, this is the URL where you can find all the slides as well as the code that Dmitry showed. If you are too quick and you're looking at it right now, the code is not there, but trust us, it will be there by tomorrow morning, because Dmitry just made last minute changes and he wanted to comment out more things and make his code more readable. So that's why it's not there, but it will be there at this URL by the time you're trying to access this. So we'll open up for questions, and if you don't have any, go enjoy the party and have good rest of the conference. So we'll open up for questions, and if you want to ask us for now, you can come here and also ask questions. So thanks for attending and have a good rest of the conference.